Rai.
Sir, can we start?
Professor Rai, good morning. Yeah, Dhiraj, you can start on time.
Participants, experts, and organizers of this short-term course for 1 week, starting from today, the 12th of October till the 16th of October 2020. 1 week online international short-term course on recent advance of 3D printing and its biomedical engineering applications is being jointly organized by Royal Global University Guwahati in collaboration with Northeastern Hills University Shillong and National Cheng Kung University Hospital Taiwan from 12 to 16 October 2020. This interactive course will provide information and resources to the participant in the upcoming field of 3D printing technology, which has widespread applications in a variety of medical and allied areas such as dentistry, rehabilitation, artificial body, organs, aerospace, consumer products, defense, automobiles, etc. Several renowned speakers from AIMS, New Delhi, CSIO, Chandigarh, NKCUH, Taiwan, IITs, NITs, and central universities have provided their consent to be part of this program and share their expertise with the participants. Instructional methods would include provisions of online reading material, demonstration sessions that include background and practical information, case studies, and interactive discussions conducted online with help of renowned speakers from academia and industry. More than 200 participants have all over the country have registered for this 5-day course. Now I'm going to brief you regarding all these three organized sessions which conduct this training. The Royal Global University. Royal Global University Guwahati, Assam is a leading university of Northeast India committed to provide unparalleled education to render holistic development to the students. It caters to 27 schools offering 130 plus courses nestled in the prime location of Guwahati. The campus is well accessible. RGU is spread over a picture of 27 acres of land with about 12 lakh square feet built-up area. The campus is secure, well-maintained, and facilitated with state-of-the-art amenities, including conducive classroom, conference rooms, auditoriums, studios, mood court, the 85 plus high-tech labs, libraries, and informatories. One of the strongest pillars of RGUs is the highly qualified and well-experienced intellectual capitals with 250 plus faculties who are also serve as the motivation catalyst for intellectual. For 5,000 plus students, learning in RGUs goes beyond the classroom and textbook. RGUs strive for academic excellence through research-intensive and industry-oriented education instilled with a strong sense of becoming a global citizen. About NEHU, the Northeastern Hills University Act 24 of 1973, passed by both houses of parliament, received the access of the President of India on May 26, 1973. It was published in the Gazette of India on May 26, 1973, together with the first schedule of the Act incorporating the statute of the university. The objectives of the university as laid down in the Act are disseminate and advance knowledge by providing infrastructural and research facilities in such branches of learning as it may deem fit, to pay special attention to the improvement of the social and economic conditions and welfare of the people of the hill state of northeastern region, and in particular, the intellectual, academic, and cultural advancement. The Nehu campus is 12,000 acres with almost 500 areas still under forest. It has excellent infrastructure and laboratories facilities. In spite of serious constraint of communication and the general lack of infrastructure facilities in the region, NIHU has established itself as an institution of higher learning and research of every high quality. It has been able to attract persons of proven academic excellence from almost all parts of the country to serve its faculty, and its student community is drawn not only from the different parts of Northeast but also from other parts of the country. In February 1996, the university set up a campus at Tura with the Department of English, Garo, and Education. A number of departments of the university now receive special grants from the University Grants Commission under its Special Assistance Program. Four of the science department, including geography, also receive grants from the UGC, SAP, COSIST program. Some of the departments have also received grants under the UGC's Departmental Research Support Scheme. In addition, a huge number of research projects have been awarded to individuals members of the faculty, notably by the CSIR, DST, DAE, UGC, ICSSR, Ford Foundation, and DBT, DF&E, and MOEF. The university is also the recipient of a number of endowments donated by the various organizations and individuals, including by Dr. Shankar Dayal Sharma, former President of India, and Justice Krishna Iyer. Nehru has also chosen for the prestigious Rajiv Gandhi Chair for Research into Protective Discrimination. Several individual members of the faculty have been honored with the highest individual member with the highest academic award in the country. Many of the faculty are also involved in collaborative research projects with University of Europe and Asia. One of the basic ways in which the university endeavors to fulfill its local responsibility as enshrined in its acts by focusing its attention on the Northeastern, it is circular program including research, the fulfillment of its global responsibilities as a member of the global academic community is evident from the number of research publications by its teachers in journals and high international review and national and international seminars and conferences which are regular features of the university's academic life. At present, there are 72 undergraduate colleges affiliated to the university, including 8 professional colleges. The University Central Library, whose membership includes university and colleges, teachers, postgraduate and undergraduate honor students, and members of the non-teaching staff, has a collection of close of 2 lakh books, 38 bound periodicals, and it subscribes to 316 foreign and 366 Indian current journal. The students have done well in their life after leaving university. Many have been into the central civil services, banking services, and into the university system. Several have been awarded scholarship and fellowship by both national and foreign organizations. The percentage of our students of clearing the NET, GATE, and other national tests is quite high. The number of students turning for their master degrees and research students working for their MPhil and PhD degrees is close to 1,700. The students, the undergraduate colleges affiliated to the university enroll about 18,000 students. Our faculty strength is just over 300. In short span of less than 50 years, NIHU has matured into an institution with a serious academic and social and cultural agenda and a clear vision for its future growth. Now NCKUH. It has been over 30 years since National Cheng Kung University Hospital was established on June 12, 1998. Under the leadership of successive superintendents, we have they have demonstrated the heroic momentum of crossing victory and heading to success like the bridge of hope and prospect. Being a national university hospital, they are devoted to their mission to protect the health of the people of southern Taiwan, heading to be the International Clinical Research and Medical Education main association. At the same time, they integrated Duolo branch cooperated with Taiwan Hospital, supported Tainan Hospital Singho branch, and has established the prototype of NCKU medical system. In addition, the national funds, it is the selfless dedication of thousands of employees and more than 30 years of golden years that glorifies NCKU Medical Center. These efforts have made NCKUH a well-known hospital brand. They have comprehensive medical team, complete equipment, high quality and friendly medical staff with warm hearts, which creates quality impression on the patient. NCKUH is truly a valuable asset for the whole people and the country. Taiwan has stepped into an aging society. The advancements of science and technology has created a rapid change in the medical technology and the public expectation for medical care is increasing. The Executive Yuan has approved the construction of the Old People Hospital under the structure of NCKUH and the establishment of the Elderly Medicine Smart Care Development Education Center. The comprehensive national major plan combining geriatrics, medical talent cultivation, medical industry and geriatrics care is scheduled to be launched in 2023 under the overall structure of the Universal Health Insurance. Medical 3.0, IT and ICT, and 4.0 all intellectual intelligence, medical operations need more dedicated and intelligent management. In this area of knowledge and information explosion, they hope to become the leader of correct medical knowledge by using the technology, media resources to pass on the correct health knowledge of the people and open up the grassroots social influence. But no matter how the technology of media personnel to listen and accompany the patient, do the patient's care, not only alleviate their physical illness but also reassures their hearts and solve patients' doubts. They believe filling in the super medical quality with warm care will inevitably create a moving service. NCKUH will allow up in the trust of the people. It is their firm commitment and second to non-social responsibility to provide services that will touch people's heart. So we hope that this collaboration of all three institutions for this international short-term course would be beneficial for all the participants who have gathered for this August occasion. Now we would like to have the inaugural session by Dr. Dinesh Bhatia, the organizer. Dr. Dinesh Bhatia pursued his PhD in biomechanics and rehabilitation or engineering from NNIT Allahabad, India, and master degree in biomedical engineering from Mumbai University. He completed his MBA dual specialization from IMT Ghaziabad. He is currently working as the Associate Professor in the Department of Biomedical Engineering, Northeastern Hills University, Shillong, Meghalaya. Since August 2013, he was selected for the Young Scientist Awardee by the Government of India to pursue research in osteoarthritis at Biomedical Engineering Department, Florida, International Osteoarthritis at Biomedical Engineering Florida, he was selected as one of the 12 young biomedical scientists by the Indian Council of Medical Research (ICMR) Government of India to pursue research following in the field of sensory prosthetics at University of Glasgow, Scotland. He was several research he has several research papers in reputed journals, conferences, seminars, and symposia with teaching and research experience of more than 17 years. He is panel member of many scientific professional bodies, editorial boards, committees, societies, and forums. Dr. Dinesh worked on several funded projects from the Government of India, also the author of 6 books and 20 books chapters till date. With more than 200 publications, his areas of interest are medical instrumentation, biomechanics, and rehabilitation engineering, medical informatics, signals and imaging processing, marketing, international business, and environmental sustainability. I invite you, sir, to give the welcome address regarding the international STC.
Thank you so much for the kind introduction. Warm greetings to all the dignitaries who are present here. Professor A.N. Raiji, during whose tenure I had joined the Northeastern Hill University in 2013. He was the Vice Chancellor of the university at that time. Sir, thank you so much for accepting our invitation and presiding over this inaugural function. We are really grateful to you, sir. And sir, as you have already informed that you will be retiring this month, so we will be missing you, sir, in the university, and we wish you all the best for your future endeavors, sir. And Professor S.P. Singh Saab, namaskar, and thank you so much for giving us this opportunity and all the support you have given us for organizing this program. We are very grateful, and along with my team, Dr. Hirak, and who has worked tirelessly, and Mr. Sasanka, who has taken care of all the IT-related things. So we are very grateful that with your kind support, we have been able to organize this 5-day program. And you will be glad to know that more than 250 participants have registered for this course. And as I am speaking to you now, my phone is continuously ringing, but I am not in a position to pick the phone. So continuously the participants are calling us for any query related to link, or they want to register for this program. So we have crossed 250 number this morning. So that is a very hearty sign. And I'm also thankful to Director Tao from NCKUH and Madam Tasai, with whom I have been continuously in touch and helping me get to organize this event. I'm also very much grateful to all the delegates, all the faculty members, all the senior professionals. Professor ML Jain is here from Indore. I'm very, very grateful, sir, that you yourself came forward on seeing this short-term course we are organizing and encouraged and motivated us. So we are very nice, and we will be happy to have you in the valedictory session to share your views with the participants. So we are very grateful to all of you. Also, I would like to thank one important person is Dr. Prabhat Chaudhary, who's from All India Institutes of Medical Science, New Delhi. So he actually initiated this linkage between myself and NCQH and RGU. So he was instrumental in getting us to hold this 3D printing program. As you know, 3D printing is now in diverse fields. It is in medical field, it is in dentistry, it is in aerospace, it is in military products, military development. So anything can be developed with the help of 3D printing. And 3D printing is going to be the future in the next decade or so. So we have amalgamation of a number of renowned speakers from different IITs, NITs who have given their kind consent to be part of this program, and who will be sharing their knowledge and expertise with all the participants who will be attending this program. So I hope that this will be a fruitful event, and many of you will gain new insights in this field and take this further for development of our institutions, our country, our society, and help those who really need your expertise in this field. So I wish all the participants and all the members who are here for their kind support and their participation in this event. I wish you all the best for this program, and without taking much time, I thank you all. Jai Hind, Kublai.
Thank you, Dr. Dinesh Bhatia, for your warm introduction. Now we would like to have the second speech from Professor Dr. S.P. Singh, Vice Chancellor, Royal Global University. Professor Dr. S.P. Singh has been associated with the Royal Group from its inception in 2009 as the founder director of the institution. He further moved to Amity Education Group in 2013 and joined as the Senior Vice President Academic of the group and was responsible for functioning of 6 Amity campuses situated in different parts of the country and abroad. He also served as the founder, Vice Chancellor of Amity University, Chhattisgarh for almost 2 years before joining the Assam Royal Global University in November 2016 as the founder Vice Chancellor. With the vision and hard work of Professor Singh, the university has been ranked the #1 private university of Assam by Education World within a span of just 3 years. With more than 3 decades of rich experience in teaching, research, academic administration in institutions of repute across the nation, Royal Group is blessed twice to have the association of Professor Singh in its journey so far. While serving his second tenure as the Vice Chancellor of Royal Global University, Professor Singh has completed almost 20 years of hardship of well-known academic institutions of the country, a geologist, MBA, and a law graduate with PhD in strategic management. Professor Singh is also an ardent baseball player and has been actively involved in various social and cultural activities since his university days. I welcome you, sir.
Good morning, all present. I reached my office. Apologies. I started attending on the and then I reached office on time. I'm thankful to God for this. Most revered Professor Rai, whom I respect from core of my heart, and I'm very, very fortunate to see you out here. And Dr. Ting Mao Chong from NCKUH, Taiwan. This is a really great occasion for me in Royal Global University. It's echoing. The Royal Global University to see that this particular short-term course, that is recent advances of 3D printing and its biomedical engineering applications. This is, I mean, in my opinion, personally, it is a great, great initiative by all 3 organizers. Royal Global University is striving. We are very new university, budding university, but we are very, very open for any kind of collaboration. And therefore, when Dr. Hirak Ranjan Das came to me and he has told me this kind of association for this short-term 1-week program, I was very, very happy to extend what all possible help I could do to organize this program. So this is a great moment for all of us. And we are very eager to hear Professor Rai. And for 3D printing, I don't know much, but there are a few things lying on my table. They are 3D printed. When we install 3D printer on our university, including, I would say that I'm having this one thing which is there, and there's so many things lying in the back. So I'm very, very keen to know more about 3D printing, but then my 3D printing experience is only limited to small devices that help me in day-to-day functioning. That may be a mobile phone holder, that may be something, very creative, that may be a bulb's shadow, or maybe that anything comes to my mind every day. I think 3D printing, but the application of 3D printing in biomedical, we all know very well. Dr. Dinesh Bhatia, thank you so much. Professor Alak Bora Gohai, who has also joined today's webinar. I think I'm seeing Professor Jain out here. Professor ML Jan, and all other eminent people who have joined today's webinar. And most important, around 252, I've been told, participants from different places in India and abroad who are attending this webinar. So my best wishes to all of you. As I said, 3D printing is not my area, but basically I am from a biology background. Many of my classmates are very renowned medical practitioners, from heart surgeon to orthopedics. So I know the importance of 3D printing in medical science, but my knowledge is very limited. I don't think so that that knowledge is relevant to be discussed here. And I think we have so many eminent people to discuss today in today's webinar, but I will be definitely attending it by the best possible way. And my kudos to all of you and best wishes. And also Dr. Prabhat Chaudhary from AIMS, who actually has initiated this kind of dialogue. And together, this International Medical Center of NCKUH, Taiwan, NEHU, and Royal Global University, if from this point onward, we will have any kind of collaboration over and above this kind of 7 days short-term program, I'm very open to it, and I will definitely love to have that association. So my best wishes to the organizer. God bless you all. Thank you so much.
Thank you so much, sir. Now we'll have this next we'll have the next speech from Professor A.N. Rai, former VC NEHU and Mizoram University and former director NAC. Professor A.N. Rai joined the Department of Biochemistry, NEHU, Shillong, as a reader in 1984 from Hyderabad University, where he was serving as a lecturer. He became professor in 1987. Earlier, he did his PhD and postdoctoral at the University of Dundee, UK. His extensive research at doctoral and postdoctoral levels had already established him as an international authority in the field of N2 fixation and related metabolism. He has continued and developed the field at the department, making a pace for his group at an international level. He had active research collaboration with Uppsala and Stockholm University for over 2 decades. He was a visiting professor at the Uppsala and Stockholm University, Sweden, for a varying period between 1985 and 2002. Professor Rai has been head of the department since 1986 to 1989, 1990 to 1993, 2003 to 2005, and the Dean of School of Life Science from 1999 to 2002. As a visitor's nominee to various central universities, as member of various committees at national level, as Vice Chancellor of the Mizoram University and NEHU, as Director, NAC, and as member of the Scientific Advisory Committee to the Cabinet and Central Advisory Board on Education. Professor Rai has made a significant contribution. He was selected Fellow of Linnean Society London and member of the Institute of Biology London in 1982. He is a recipient of Young Scientist Award Biotechnology 1996 and honorary DSc Rani Durgawati University. He has delivered 16 convocation addresses. With over 36 years of postdoctoral teaching and research experience, Professor Rai has supervised 5 PhD theses. His main research interest is in microbial biochemistry, plant-microbe interactions, and cyanobacterial physiology and biochemistry. Professor Rai has 99 publications, 4 books, 32 books chapter, 62 research papers, and 1 technical report. He has served on the editorial board and has been referred for many journals and funding agencies. He has 2,200 citations. Sir, I welcome you to give the inaugural address for the International STC.
Dr. T.M. Chow from Taiwan, NCK University Hospital. Professor S.P. Singh, Vice Chancellor of Royal Global University and a good friend. Dr. Dinesh Bhatia, my colleague from NEHU. Dr. Hirak Ranjan Das, again from Royal Global University, Guwahati, who is a co-host. And dear participants, distinguished speakers, I see some of them. And I've seen in the list of speakers, which is very impressive. I wish you all a very good morning. Thank you for all the three organizers for the invitation extended to me for this inaugural session. I consider it a very important webinar internationally, which is on the advances in 3D printing with relation to biomedical engineering. As I heard from Dr. Bhatia, quite a large number of participants are able to participate. Many, unfortunately, may not have been able to register because of the shortage of time. But all those who have registered, I'm sure they are going to have a wonderful time over the next 1 week, learning what are the advances in 3D printing, particularly for biomedical application. I need not elaborate too much on this topic, because looking at the program, I see the different aspects will be covered by different experts. But I'm impressed with the planning and the comprehensive nature of the program. Most of the aspects are covered in this 5-day program, which are related to modern 3D printing and its application. Also, they have been able to get hold of very senior and eminent speakers to service these topics, which is again a very, you see, these days webinars have become so common that, off the cuff you normally ignore it. But I really am impressed with the trouble they have gone to in arranging the speakers, because they are the most key ingredient in the success of this webinar. You see, in simple terms, to me, the 3D printing, what it allows us to do is devices and the materials required for medical applications. Some of them are so sophisticated or intricate that is very difficult to manufacture by machine tools. Such devices are 3D printing allows them to be produced, which will find it very difficult to do it by machine tooling. So its application is increasing day by day. If even that Professor STC Singh was showing something 3D printed, I look at Calcutta airport, the whole idol of Puja, Durga Puja, was put there in 3D printing. But the intricate devices are the key. Because the medical devices are many of them are life-saving devices. Of course, large number of them are diagnostic in nature. So there's a great interest in this field. I see that you are covering surgery to medicine to dentistry to general health care, oral health, other clinical application, including future prospects, that what are the likely scenario for the future. Some of them are also using nanotechnology. I see that nano-engineered 3D dendrites and their applications are covered in this program. The implants, different kinds, these are very important, because many of these implants are very tricky and minute to manufacture, and machine tools find it very difficult to be able to do it. Micro surgeries or even major surgeries, these applications are there. Designing biosensors, you name it, and everything that we were producing through machine tools is possible to do it through 3D printing, and much more than that. And therefore, I see that this webinar will be of great use to all the participants, including some of us who are not medical practitioners, we are basically biochemists, but we use devices, integrate devices in research. So these things are even useful there. Many of the devices which are they're able to print by 3D. I wish you all a very fruitful deliberations over the next 5 days, as I see in the program, and hope that these deliberations will be greatly useful to participants as well as experts, because you see some of the experts, they are experts in a particular area. Since several areas are being covered, even the experts will learn from each other through interactions during this 5-day period. So at the end, I would congratulate all the organizers for this very timely, I would say, a webinar and very useful one. And congratulations to both Bhatia and Professor Singh to be able to bring on one platform so many experts, and even University of Taiwan, the University Hospital, Taiwan. Thank you very much for inviting me also. It also gave me an opportunity to see at least the faces we are SP Singh and Borgohain and others, because in this lockdown, it has become very depressing. We are just facing the computers. So it will be very nice. I think in this seminar also, many speakers will be able to see each other. Many of you will be friends, meeting after a long time, all face to face. So thank you very much. A very good morning to all of you again, and wish you all the success. Thank you.
Thank you so much, sir, for your kind words of encouragement and sharing your experience with the participants. It's a privilege to have you, sir, to preside over the inaugural function and accepting our invitation. Sir is due to retire this month from NIHU, and we wish you all the best for your future life and health. Now we're going to have the next speech from Dr. Ting Mao Cho, Vice Director, NCKUH Taiwan. Dr. Mao did his degree from the College of Medicine, National Chengku University from 2002 to 2006. Presently, he is working as the Vice Director, International Medical Center, National Chengku University Hospital 2023. He is also associated with the project staff, Medical Device Innovation Center, National Chengku University 2019 to date. Adjunct attending physician, Department of Plastic Surgery, ED's Cancer Hospital 2019 to date, and Consul Kong Tai Metal Industrial Corporation Limited 2017 to date. He was also the General Manager, Healthway Biomedical Corporation Limited 2019 to date. He has vast leadership and management experience with several publications in the reputed journal. Sir, I welcome you to give the speech.
Good morning and good afternoon, everyone. Professor Singh and Dr. Bhatia, Dr. Jain, and Dr. Rai. Good morning to all of you and all the precious guests who are online with us. I'm Dr. Ting Mao Cho. I'm the Deputy Director of the International Medical Center of NCQH. And first, I want to thank you all for being with us today, joining this short-term course. I believe in the following 5 days, we can have a good chance to learn from all the experts from India and from Taiwan to learn the recent advance in 3D printing and its application in medical and bioengineering fields. So I learned that it has been forecast that the 3D printing in medical fields will be worth $3.5 billion by 2025. And it accounts roughly 13 to 15% of all 3D printing related revenue. That is a great scale. And also the industry's compound annual growth rate is supposed to be like 17, 18% by 2025. So from prosthetics to surgical guides, I think there are a surprising number of medical applications for additive manufacturing technology, and the flexibility offered by a 3D printing service lets us, all the medical professionals, create a patient-specific device at an affordable cost. So in the past decade, we perceived great power and energy in developing 3D printing in India. We learned from many reports about the first case who underwent implantation of 3D printed hip joint, and also patients who underwent the implantation of bioengineered ear implants. And also we see the rapid growing of the company Think 3D and how it entered into an agreement with AP MedTech Zone to set up India's largest integrated 3D printing facility. All these reports let us know and feel the great power and energy of India in these fields. So I believe in the following course, we can learn a lot from all the experts in India in this growing field. And in terms of 3D printing development, Taiwan also has a quite good infrastructure for all related developers. In Taiwan, there are several companies who can provide high quality service for medical 3D printing, especially in the Southern Taiwan Science Park. These manufacturers have been TFDA approved and also comply to GMP regulations. There are also companies who manufacture 3D printing facilities, 3D printers, either plastic or metal. Also, if you need polishing or surface treatment for your printed metal objects, you can easily find suppliers with excellent CNC techniques and surface treatment technologies. Also, you can even find a few companies in Taiwan who can provide quite fine metal powders for powder metallurgy. Moreover, many labs in the medical centers in Taiwan are now developing bioprinting techniques. So we can proudly say that there is also a cluster here in Taiwan to provide everything you need for medical 3D printing. And since 1999, the Department of Medical Engineering Research Team in NCKU has been working with surgeons. They tried to utilize the 3D simulation techniques to fulfill unmet clinical needs coming from doctors. And these techniques allow surgeons to obtain more precise pre-operative information to improve the efficiency of the surgery and achieve better outcome, and also to reduce complication rate, especially for the difficult and complicated cases. Additionally, doctors can explain the treatment strategy or surgical planning to patients and their family members in a more precise and understandable way with using the 3D simulation and printed models. So in 2015, NCQH published several cases undergoing mandibular reconstruction due to cancer resection using 3D printed mandible model for pre-op simulation, plate shaping, and also intraoperative guidance. So during my chief residency in the NCKU hospital, I also joined several cases using the intraoperative guide for maxillofacial surgeries, maxillofacial corrections. And these techniques actually helped us to achieve a better outcome. So this technique not only greatly reduced our surgical time by 20%, but also helped plastic and oral surgeons to achieve a better symmetric outlook for all these patients. And this year, due to the pandemic of COVID-19, face masks has become essential for every citizen in their daily life globally. However, wearing a face mask for a long time often leads to ear discomfort and facial compression marks. So these conditions are more often observed in medical personnel. So therefore, a special unit in NCKU called the Maker Factory developed a face mask pressure relief pad. This pad is made of PLA thermoplastic material and is 3D printed to be tailored to your face contour. In addition, the thermoplastic nature of this material offers an extremely good fit to your face. So at present, NCKU Maker Factory allows open access of the 3D printing source code on the official website, hoping to help all medical personnel to get over this tough moment. So from this report, we also learned that the 3D printing technique not only help us in what we do every day, but also help us to get through this tough moment caused by COVID-19. So at last, I want to send my best greetings to all the audience attending this course in the following 5 days. I deeply believe that learning from all the experts from India and from Taiwan could bring us a very fruitful journey to learn more about 3D printing techniques and what benefits it can bring us. So I wish all the audience can enjoy the 5-day course. Thank you very much.
Thank you very much, sir, for your kind words. Now we're going to have the next speech from the word of thanks from Dr. Hiraranjan Das, the organizer. Dr. Hiraranjan Das completed his Bachelor of Engineering in Mechanical Engineering from Assam Engineering College, Guwahati in the year 2001 and completed his postgraduate diploma in CAD, CAM, CAE from CPET, Hyderabad in 2006. Further, he completed his Master in Mechanical Engineering in the field of Thermal and Fluid Mechanics from Assam Engineering College, Guwahati in the year 2012. From the year 2003-2011, he has worked in various industries and private companies. He joined as lecturer of Mechanical Engineering in Royal School of Engineering and Technology, Guwahati, Assam in the year 2011. In the year he was promoted from lecturer to assistant professor in the year 2012. He has organized more than 20 events, including Vikram Sarabhai Space Exhibition (ISRO), international short-term training programs and conferences in various fields like CAD, 3D printing, IoT, and robotics. While working as an assistant professor at Royal School of Engineering and Technology, he has completed his PhD program from Assam Science and Technology University in the year 2020. He has 6 international journals and 19 conference publications in his name. He is also working as for institutions, innovation councils, Royal Global University as the head coordinator and taking keen interest in research and development. So I welcome you to present the word of thanks.
Thank you. Thank you. It is my privilege to present a vote of thanks. So first, I would like to thank our Vice Chancellor, Sir, Royal Global University, Professor Dr. STC, who is always inspired us for organizing such events and more. So in these pandemic situations like COVID, which lead us the momentum of this event. I would also like to thank Honorable Farmer Vice Chancellor, Sir, Professor A.N. Rai, then Dr. Ting Mong So, Deputy Director, IMC, National Chang Kung University Hospital, Taiwan, Professor M.L. Jain, Sir, and all the participants from the globe like Asia, Europe, and Africa. It is my privilege to present a vote of thanks to the honorable delegates who blessed us with their presence and took the valuable time of their busy schedule. Also, I would like to extend special thanks to our academic chairperson, A.K. Buragoy, sir, for his continuous inspiration and motivation. I extend my big thanks to the 3 most important persons without whose an active role, this event won't be possible. Dr. Dinesh Bhatia, first of all, then Mr. Sasang Borua, then Vijay Kalita, whose immense patience and dedication, especially to take such huge tasks during the pandemic situations, successfully organizing the program. In the near future, we are coming up with few more short-term courses in the field of Wi-Fi mesh network, LiDAR, that means leak detection and repair technologies, and image-based physiological disease detection. We will send the invitation prior to the STC. Hope all of you will enjoy all sessions and learn a lot of new things in this field. Thank you, all the participants and DC sir, then our ML Jain sir, who is also inspiring us a lot in this event. Thank you.
Thank you so much, sir. Now we will have a break for 5 minutes, and the next talk will start at 11 a.m. sharp by a speech from the speaker.
Thank you so much. Thank you, everyone.
Thank you so much, sir. Thank you, Professor Singh. Thank you, Professor Rai. Thank you, Professor Bhagwan.
Wish you all the best.
Thank you, sir. Thank you, Dr. Chow. Thank you so much for blessing the occasion. Thank you so much. We will start next session in 5 minutes. Next speaker is Dr. Lee Chai Lung from Taiwan. So he will be speaking. So within next 5 minutes, we will be starting. Thank you so much.
Thank you very much.
All of the doctor and the professors. I'm Jialong Li. I'm an orthopedic surgeon in the Tainan Hospital in the South Taiwan. I have some experience about 3D printed jig in the orthopedic surgery. So today I will introduce the 3D printer in orthopedic surgery.
Dr. Shalom.
Yeah.
Yeah, just give 2-3 minutes because we have given some break to the participants. We have given a break, so just give us 2-3 minutes and we will introduce you, then you start your talk.
Okay.
Okay. Just we have given them 2-3 minutes break.
Okay.
Thank you.
他们要那个，他们那个嘛。
他等有一些参加者还没有上线。
From the different speaker. Now the first speaker of this session will be Dr. Lee Cheng-Lu. Dr. Lee is currently a physician in orthopedics department at Taiwan Hospital, Ministry of Health and Welfare, Taiwan. Dr. Lee has done his master degree from the Department of Physical Therapy, National Cheng Kung University. He has worked as the Chief Resident, Department of Orthopedics, National Cheng Kung University Hospital and Residence, Department of Orthopedics, National Cheng Kung University Hospital. He's been working as a fellow research, Department of Orthopedics, University of Tokushima, Japan. He has been attended numbers of physicians departments like orthopedics, trauma, and others from the National Cheng Kung University Hospital, Duoluk branch. Dr. Lee was an expert in osteoporosis treatment, endoscopic spine surgery, minimally invasive plate osteosynthesis, high tibial ostomy, ultrasonic guidance for needle placement, and some other specialization. Now I welcome Dr. Lee Chenglu to present his speech on the title Three-Dimensional Printing in Orthopedic Surgery.
Thank you for the introduction. Good morning and good afternoon, every doctors and professors. I'm Jialong Li. I'm a medical doctor. I'm an orthopedic surgeon in the China hospital. I have little experience about the 3D printed jig in the orthopedic surgery. So today I will share the limited experience to everyone. 没有跳，还是可以吗？没有跳。
他没有跳。对，你这不会自动啊？
它现在后面没有动。
对。
In the past, we get the patient information from the plan film, and we have to imagine the relation of structures in our plan. With the invention of computer tomography and the computer program, 3D reconstruction is available in our daily practice. Moreover, 3D printer become popular and inexpensive. It makes the digital image to become actual objects. With the technique of additive manufacturing, one can produce the customized prosthesis and patient-specific instruments. There are some clinical applications in the orthopedic surgery. In the joint reconstruction, we can use the personalized patient-specific instrument for the total knee, uni knee, and the high tibia osteotomy. And we can create the mobile antibiotic load cement spacer. In the spine surgery, we can use the 3D printer for the difficult screw-in trajectory. In the trauma surgery, we can use the 3D printer to make the acetabular fracture more easy to manage. In tumor surgery, we can also use the 3D printed jig to help us to do the tumor resection. First of all, I will introduce the osteoarthritis of knee. OA knee is a common disease all over the world, and it's a condition of progressive loss of the joint cartilage. The treatment of the knee OA include the non-operative therapy like the medication with NSAID or rehabilitation. Surgical intervention may be needed if the conservative therapy failed. And there are different operative methods, including the high tibia osteotomy, uni-compartment arthroplasty, and the total knee arthroplasty. It depends on the different situation. For the older age people, joint resurfacing procedure like uni knee or total knee is favored for the whole patient. But the joint arthroplasty is require the bone cutting for the implantation of the prosthesis. And the alignment of the prosthesis is very important because it will influence the functional result and the longevity of the prosthesis. In in this slide, we can see if a malposition of the prosthesis, it will cause the loosening of the prosthesis, and we need to do a revision surgery. So in the past, we do the bone cutting for the knee arthroplasty. We have to use lots of instrumentation. Just like in the femoral cutting, we need to put a guide pin into the femoral canal and set the preoperative varus angle, and then we can place the guide pin and put the cutting jig and then cut the bone. So it's and the instrument is always very huge and bulky. So sometimes it will affect by the soft tissue. So it makes it difficult for the place precisely. It's also similar totally in the TBR bone cutting. So with the advance of the 3D printer and the computer science, now we can use the computer-assisted surgery. It can improve the accuracy and the precise of surgical intervention. There are two ways of computer-assisted surgery. The first one is the computer navigation. We can use the digital imagery with the digital camera for the surgery. And another is the patient-specific cutting guide. We can use the 3D print to print the guide as a computer-assisted design. This is the navigation system for the total knee arthroplasty. It will increase the accuracy of the precision of the prosthesis. And we need to use the camera and the tracking system. In order to put the tracking system, we have to create another pinhole, and it will increase the risk of fracture. And the surgical exposure should be big enough for the camera. Another computer-assisted surgery is including the robot arm. The robot arm is used in combined with the navigation system. It helps the surgeon to do a more precise bone cutting. Both of these two systems, navigation and the robot surgery, there are some cons because we need to do the registry for the navigation, so it takes the time to do it. And the addition pinhole will increase the risk of fracture. And we always need a bigger surgical incision and a longer surgical time than the patient-specific instrument. And as we know, the navigation and the robot system is very expensive, and not every hospital can afford for this navigation or robot system. So another way to do the computer-assisted surgery is a patient-specific instrument. It is created by the 3D printer. We can design the instrument with the computer assistant and print the jig with 3D printer. In this picture, this is the commercialized PSI for the total knee arthroplasty. We can see we just put the femoral jig in the femoral bone, and you can place the cutting guide pin. It is more easier than the traditional one. You don't need to violate the intramedullary canal, and we will have less bone loss. We can have less bleeding loss. And then we can also put the PSI on the tibia, and then we can place the guide pin, and then we can do the bone cutting. So the PSI made the joint replacement more easily and more occurrence. There is another surgery for the knee osteoarthritis. The high tibia osteotomy is a joint preserving surgery. It's suitable for the younger patient with the medial compartment osteoarthritis. After we do the proximal tibia valgus osteotomy, we can correct the mechanical axis, and we can unload the medial compartment pressure. This is an image of the varus knee. We can see the preoperative mechanical axis is over the medial compartment of the knee joint. So with the increasing pressure in the medial compartment, it will cause the osteoarthritis. And after we do the proximal tibia open wedge osteotomy, we can adjust, we can change the mechanical axis of the weight bearing. And the idle mechanical axis is the Fujikawa point. It's about at the 62.5% of the tibia plateau. And in the conventional, if we do the conventional HTO, we need to check the weight bearing axis by the fluoroscope. So every time we adjust the open wedge size, we need to check the mechanical axis to achieve the idle weight bearing point. So we need to, it takes time, and we need to have more X-ray exposure. So there is a innovation of HTO by 3D printer PSI jig in Taiwan. This is a commercialized product in Taiwan, and it's very mature. This commercialized PSI for HTO is processing by using the CT image, and for the occurrence of the cutting, we need the 1 millimeter ACL image of the CT scan. With the image, we can reconstruction the bone. After reconstruction the bone, we can calculate the corrective angles from the full leg X-ray, and then we can simulation of the correction on the computer, and later we design the PSI to achieve the bone cutting. This is the simulation of the open wedge. We can see in the different size of open wedge, the mechanical axis is in the different position. So this is the final product of the PSI. We can see this PSI have some difference. We can see there is a 2 cutting guide, because we do the double bone cutting for the higher union rate. So there is a 2 cutting slot, and the most convenience is the alignment hole. We can see there is a 2 alignment hole. If we not achieve the planned open wedge, it's very difficult to pass in a rod by the alignment hole. So if we achieve the size of open wedge, we can place a rod to pass in the alignment hole. So we can know it's achieved the open wedge size. So this is the case of high tibia osteotomy. We can see this is the varus knee and with the medial compartment osteoarthritis. The weight-bearing mechanical axis is in the medial part of the knee. So we need to create the open wedge in the medial side of tibia. So we design the open wedge, the bone cutting, and we leave a little bone nut cut as the lateral hinge. So with this PSI jig, we can do the precise bone cutting and the open wedge. This is the intraoperative image. We can see after we achieve the open wedge, we can pass the alignment rod to pass the alignment hold. And we only need the 4 to 5 centimeter incision to do this procedure. And we don't need the fluoroscope to check the alignment. After the correction, use the PSI jig, we can see it's very, the mechanical axis is very acute passing the point as we planned. And due to the double cutting, we can see the bony union of the high tibia osteotomy is very good. And sometimes we can use the PSI for the difficult case. This patient have a proximal femoral fracture malunion, and this malunion aggravate the medial compartment OA. So we cannot do the high tibia osteotomy alone due to the proximal femoral malunion. So in this case, we choose the double osteotomy. And we know the malunion is over the proximal femur, but due to the low union rate of the proximal femur, so we design a distal femoral osteotomy, and we also do the close wedge with the PSI, and we do the open wedge in the tibia. So after the correction, we can see the alignment is very good to pass the medial point of the knee joint. And sometimes we can see the very large deformity of the knee. And in this case, is a large deformity of the distal femur. But the large deformity cannot be single open wedge to correct the deformity, because the large deformity will, if you use the single open wedge osteotomy, the bone gap will be very large, and it's very difficult for the union. So in this case, we use the hybrid osteotomy technique. We do the open wedge in the lateral side, and the medial close wedge in the medial side. And for the correction angle, we need the very precise bone cutting and the length of the turn point. So with the PSI, it makes the bone cutting very easy. And we can achieve the good alignment as we plan. Periprosthetic joint infection is also a very devastating complication following the knee arthroplasty. And the two-stage revision is the gold standard for the treatment. The first stage is to remove the prosthesis and do the adequate debridement, and then place the antibiotic load cement spacer. After the infection control, we do the revisional total knee arthroplasty. But there is two types of the antibiotic load cement spacer. there is no difference in the infection irritation rate, but there are differences in the functional outcome and the easy and the difficult for the reimplantation. The articular space, as we know, the mobile antibiotic load cement spacer, it has a superior functional outcome and result in easier reimplantation and allow the decrease of range of motion between the stages. So it's become the popular in the treatment of the periprosthetic infection. However, most of the mobile cement spacer is handmade in Taiwan, so sometimes it's not very well fixed, and there sometimes have the complication. So in China Medical University Hospital in Taiwan, the doctors and the engineering develop a method to improve the self-made cement spacer. They use a 3D computer model with a reverse engineering technique to make the 3D model of the commercial revision knee system, and use a 3D printer to make the prosthesis and the corresponding models for making the cement spacer. They use the computer aid design the prosthesis and to do the corresponding marks. The computer aid design articulation trial and the spacer has a perfect contour and the ultra high joint congruence. Then other handmade mobile cement spacer. And in the design, when they added lots of small pieces for the bone surface, it will increase the cement anchoring and the better fixation for the cement spacer and the bone. And the durable CAT trial and the silicone models are very high cost effective method for cement spacer fabrication because they can easily clean, sterilize, and reuse. This is an image of the cement spacer. In this way, we can create a very high congruence cemented spacer, and it's very suitable for the patient in the infected knee. So the CAD articulation spacer have the same high infection irritation rate, and it improves the clinical outcome and increase the range of motion of the knee. And due to the well fixation, it decreases the mechanical complication. There is another case I'm going to show is the PSI for the difficult school trajectory. As we know, the atlantal ACL instability it can be treated with the C12 transarticular screw, but it's very technical demand, and there is a risk to make the neurovascular injury for the vertebral artery and the nerve of cervical nerve. So when design a PSI jig for the C12 screw, we use the CT image and create the 3D bone model, and we design the trajectory of the screw, and we communicate the screw position with the engineering, and then they can do the guiding jig. They can do a guiding jig by the 3D printer, and we can use the guiding block to insert the screw very very safely and correctly. This is the intraoperative image. And after 3 years follow-up, the screw position is still good, and the patient symptoms improve after the surgery. Another PSI is used for the customized osteotomy. In some very rare case of the sarcoma tumor, we need to do the bone cutting, but due to we do the posterior approach only, so sometimes it's very difficult to know the bone cutting region. So we do the visual surgical planning on the image and communicate with the engineering to create a customized osteotomy guiding device. We choose the area of the bone resection, and then we can create the cutting bone cutting jig. We can do the osteotomy. So this is the intraoperative osteotomy guiding device. We can do the adequate bone cutting in the precise region, and after the bone resection, we can still have lots of bone preserving and to prevent the instability of the sarcoma. And the patient achieves the clinical outcome after the tumor incision. There are also some PSI for the surgery, and for the 3D print model is also make the acetabulum fracture more easy. In a 3D print model, it allows surgeon to more recognize the fracture pattern. And with the mirrored model by 3D printer, we can do the better plate contour before surgery, and it saves the surgical time and accurate plate contouring. In this case, we can see that this is the malunion of acetabulum, cause the hip joint subluxation. And this is a computer image of the memory acetabulum and the malunion acetabulum. So we need to do a cross wedge. So you can design a cross wedge cutting jig to help you do the osteotomy. And we can see after the osteotomy, the result is good. And this is a case of osteochondroma of the pelvis. So they need to do the hemipelvectomy. And after the bone resection, they lost the right side of the acetabulum. So use the 3D printer, we can create a customized endoprosthesis for the joint reconstruction. And in some revision total hip, it's very difficult with acetabulum defect. So with the 3D printer, we can create acetabulum with the titanium arrow to fill the bony defect. And the position of the acetabulum, you can use the PSI guiding jig. So the mental 3D printer can produce the implant with a complex shape and tolerance internal structural control to the micrometer level for the bone ingrowth. And the tumoral endoprosthesis reconstruction with the favor easy safety profile. So the conclusion is that computer-assisted surgery needs the digital image and the preoperative planning. PSI by 3D printer are useful both in the simple and the complex surgery. It helps to saving the time, increase the accuracy, and reduce the difficulty of the surgery. More innovation are required not only for the patient-specific instrumentation, but also the patient-specific implants. This is my lecture. Thank you for your attention. Huh? Yeah. 那他们刚刚是把那个关掉。
Any question?
我们这
你看他
边建议
关了。从点去。对，生日的，你这不见了。对。要的8个。这样关主持的，不然问我主持哦。哎，可是那女生刚有上来，她现在要下去啊。那不然我就只好帮她回答了。你自己看一下右边，就是问题的，如果你可以回答的，就问你，吧，你就回答。因为那个只剩。Talking about research， 哪一个？哪一个的那个
Also, any method for osteogenetic, which 3D print technique is most osteogenetic? 我想还是我可以用打字的，对。Which 3D print?
How will be the future of computer representation?
Based out of Bangalore in India. Today we will speak about medical device innovation with 3D printing. My former speaker spoke a lot about 3D printing and robotic assisted surgery. This is a relatable topic, but we're going to talk about both 3D printed assisted surgery as well as how medical device community is using 3D printing to enable better device product development as well as enable better healthcare overall. So before we start a little bit about my company, I come from a company called Altem Technologies. We are based in Bangalore with headquarters in Bangalore and regional offices all across the country. We've been operational for almost 10 years now. And beyond 3D printing, we have other solutions in terms of CAD, simulation and analysis, 3D scanning, so on and so forth. In 2017, we were awarded as the most innovative 3D printing company of India. So that's a little bit about us. And we have more than 400 customers in different industries, from automotive to aerospace to healthcare to education institutions to IT and electronics companies, so on and so forth. Now, before I explain how 3D printing is enabling a betterment in medical devices, let's talk a little bit about what medical devices are and what are the types of medical devices available. So the term medical device can be used to classify anything that can be used to diagnose, monitor, or treat a particular disease or a condition. For example, the images that you see on the screen, you see a pulse oximeter, which is used to measure or diagnose the blood saturation level. You have a thermometer, which is used to check your body temperature, as well as on the other side of the screen, you have devices like ventilator, pacemakers or stents and implants, which are used to correct a particular defect or deformity or anomaly, such as a breathing difficulty or a blockage in the heart, so on and so forth. Typically, medical devices are classified into three categories: class 1, class 2, and class 3. Class 1 being the non-invasive, the basic risk-free medical devices. Yeah, objects like stethoscopes or thermometers will fall into that category. Class 2 are going to be the slightly more moderate risks ones, such as surgical instruments, for example. And class 3, which is the most risky and hence most beneficial, are devices which are invasive in nature. What I mean by invasive is that these are devices that actually go inside the human body. So things like implants, or things like surgical guides, or things like pacemakers or stents. These are the kinds of devices that are classified into class 3 devices. Now, globally, medical devices is a $400 billion market. And typically, this can be categorized into diagnostics and imaging equipment, so things like X-rays, CT scans, MRI scans, followed by surgical instrumentation, followed by surgical appliances, followed by implants. So this is a general category. Indian market is a very small portion of the market, yet it's not that small also. So that's about a $7 to $8 billion, $6 to $8 billion market. The unfortunate part is that 80% of the medical devices that are used in India are imported from overseas countries. Now, this poses two major challenges. First, it increases the cost of the devices. Anything that has to be imported will be manufactured, let's say it's manufactured in US or Europe or even in, say, countries like China. You add up not only to the device cost as well as to the imports and customs charges. And the second problem is that because these are very expensive, they become a little inaccessible to the masses of the country. We saw a huge debate around this when the COVID-19 crisis just hit, and we figured that maybe the amount of ventilators or even basic medical devices such as PPEs or pulse oximeters will be shortfall in India. So the opportunity is to enable Indian medical device manufacturers, whether it be larger companies who have set up shop in India or startups, to make in India, for India and from India, and hence be able to reduce the cost and imports, and thus maybe fulfill the vision that our country is hopefully heading towards of the self-reliant or the Atmanirbhar India. Now, medical devices can be classified into two parts: generic ones that must work for also, for example, things like thermometers or things like pulse oximeters or things like even ventilators are general devices. You know, I'm not going to have a ventilator for me, which will be different for a ventilator for, say, some other person. It's a standard device. And then there are patient-specific ones, which are specific to a specific issue, like my former speaker spoke about surgical guides or implants. These are devices that are fabricated for a particular person. And the common objective is that they should be safe, efficient, and affordable. And the journey to develop any medical device is a very complex journey. Let's have a look at it. The process starts with understanding. So let's say I have to develop a device. So first thing is I need to understand how that device is going to solve the particular anomaly or the particular problem. Second is to create idea and a design. When I say design, I talk about electromechanical design. Next is you have to create a working prototype, test it and validate it, and then approve and deliver. Now, this journey from design to approvals is perhaps a very stringent journey, because we are dealing with a matter of safety and efficacy in devices, and especially when we talk about invasive devices, it must ensure that these devices are safe. Hence, the approvals process is very, very stringent. Hence, the entire journey is very long. Now, designing is simple. When the COVID crisis hit, even we saw some automotive and car manufacturers, they were able to very quickly design and create prototypes of ventilators. But so designing is easy, and we have a lot of design skill in our country. But approvals and validations are very, very tedious and challenging. And hence, prototyping or creating correct working models becomes very, very important. Now, if you look at a prototype can be classified into two categories. First is the prototype of the device itself, and second is the anatomy that you have to test the device on. For example, if I have an orthopedic implant, I have to create the prototype of the orthopedic implant, but I also need to have an anatomy or a representation of the anatomy that the implant is supposed to fit on. For example, if I have to prove that a particular orthopedic implant will conducively grow on the bone structure, then I need to show that in action. And that's what I'm principally going to talk about today. So prototype is basically three things. It tells you the form of the apparatus, the fitment of the apparatus with respect to the different sections, and the function. And the fitment and the function are crucial on the very, very crucial on the anatomy. So now let's talk about a little bit about 3D printing. We're going to pause that topic and talk about a little bit about 3D printing. So I don't need to explain 3D printing to you. It's a fairly common topic. I'm sure you've heard and seen about it a lot. But principally, when we think about 3D printed parts, we think about stuff like this. Strong and functional parts that are typically used in the engineering sector in the heavy industry. But there is also a section of 3D printing which has the capability to produce multicolored, multi-material objects. Parts where you can combine rigid materials, soft materials, transparent materials, different materials of different physical, mechanical properties and create a full color subject like this. And this enabled 3D printing to go from engineering to design. Now, let's come back to this. A prototype is form plus fit plus function, and fitment and function are heavily dependent upon anatomy. Typically what happens is when companies are testing medical devices, they will use cadavers or animal organs or synthetic organs. The problem is that human cadavers are difficult to access, they're expensive, there are heavy government protocols. So what if you could even fabricate anatomy or test anatomies on demand? And that's exactly what this multicolor, multimaterial technology we're using for, where we can create different types of anatomies, different types of pathologies to be able to test in the lab and represent them in a different color and different material so that the testing people can get a very good idea of what the anatomy represents. The technology that we use to do this is a technology called PolyJet. PolyJet is very similar to how a paper 2D inkjet printer works. So like how a paper 2D inkjet printer jets ink on a piece of paper, PolyJet jets liquid material. What you can do is you can create multicolor, multi-material parts. So here I've done the skull body in a rigid material, the nerves and the tissues in a soft material in a different color, and then the tumor in a different color, different level of flexibility or rigidity. The objective of doing this job was to assist the surgeons in virtual surgical planning or pre-surgical planning. So where a surgeon can, before he cuts open the actual patient, can practice a surgery on this and remove the tumor as a practice operation here before getting into the actual surgery. What we are able to fabricate is not only with PolyJet, is not only something that looks like a heart or looks like an organ, but also we are able to create materials. We have materials which behave like the actual organ. So if I talk about this heart, for example, I have materials which behave like real tissues. What that means is that when you're testing on these devices or when you're performing a virtual surgery on these devices, the tactile feedback that you get into splicing or dissecting a real organ, whether it be a soft tissue organ like a heart or a hard tissue organ like a orthopedic structure like a skull or something, you get a similar feedback. And this is a technique we call as digital anatomy printing, where we have specialized materials and specialized software where you import the 3D model of the anatomy and tell the software, okay, this is a blood vessel or a general anatomy or a heart or a skeletal or muscular or a neurological surgeon, and tell what is the subanatomy. So is it a blood clot? Is it a reinforcement? Is it a tumor? And the system automatically creates an organ or a twin organ which replicates the true biomechanical nature of the real organ. You can test your medical devices on it. We worked. We worked with some of the top medical device organizations such as Medtronic or Jacobs Institute to develop these materials, and we can create anatomies on which accurate testing of medical devices can be done before moving into the final rounds of testing, for which you may compulsorily need a cadaver or a synthetic organ. Now the problem is that while many large companies like Medtronic or GE or these kind of people or Baxter or Stryker may have the access to send their teams globally, and spend a lot of money and get their device testing done. A lot of Indian homegrown startups may not have that kind of flexibility. So technologies like this, where you can simulate anomalies and pathologies in almost every organ in the human body in the lab, can enable you to, in a very cost effective and in a very simple manner create a test scenario where you can finalize your medical device and maybe in the last stage approach the government or a private entity and start getting the devices. Now, another thing is to actually create the medical device or surgical guides as my former speaker showed us, so that we can do it using technologies like FDM or stereolithography. Again, we can use 3D printing technologies to create prototypes of the device itself. So, for example, say this is a medical device. So the casing of the device I can create it using a 3D printing technology, or using biocompatible material I can create surgical guides which can be patient specific and can be used in orthopedic surgeries to actually position and fit the implant in the place, in the correct place, in materials which are biocompatible and safe for tissue and skin contact. An example of how one company in India is using 3D printing to create medical devices. So you see the anatomy is printed as well as the device is printed. Both of them are fit together and checked. If because these are patient specific, you don't want to get into a scenario where a surgeon will cut open the body of the patient and then see that the implant or the device is not fitting. Similarly, we can also create patient specific medical devices like the splint, which was created for a juvenile arthritis patient, where we 3D scanned the patient's arm, created a device specific to him. We were also able to do some topology optimization and create a lightweight as well as structure, which gives us the ability to have an airflow. These kind of devices are becoming extremely popular these days. Another thing is implants. Now, implants can also be directly 3D printed in metal or in some sort of polymer, but those techniques are very expensive and hence not very accessible to a lot of people. So in this case, to create an implant of the eye socket, we created a mold and then poured PMMA into the mold, and that implant, that material from that implant is directly implantable or is certified to be implanted into the body. So even if you do not have access to some of the technologies that can create direct implants, such as DMLS or high temperature polymer printers, which can create direct PMMA and PEEK implants, we can always look at alternative hybridization methods to create devices. So now coming back, there's a huge scope and opportunity to create medical devices in India, for India, from India, make it more accessible to the world, make it more accessible to Indians, and 3D printing can play a very instrumental role, whether it be prototyping of the devices itself, prototyping of patient-specific solutions, or prototyping of anatomies to avoid the expensive cadaver or animal testing. Thank you so much for your time. If you have any questions, we can take them now.
Thank you so much. Thank you so much, Mr. Abhishek, for your nice and informative talk. There are some questions. What is the name of the software you are using for designing?
I'm assuming when you say designing, you are talking about design of medical devices. So the process is something like this. Medical devices can be designed using any CAD software, but I talk about, let's say, implants. Okay, so implants are designed on anatomy, right? So what happens is, and that anatomy is generated from a patient's CT or a MRI scan. Now there are tools like materialized mimics or 3D slicer or Invisilacious or D2P from 3D systems, which can be used to design. So what happens is these softwares take the anatomy of the patient, reconstruct it into a 3D model, and then give you tools to design devices around it. So yeah, materialized mimics is one of the more popular ones that is used for these kind of designs. And these are tools which are US FDA approved. So your devices are conforming to global standards. One more question is.
Yeah, one more question is that what material you use for designing 3D printed tissue or cells?
Yes. So the 3D printed tissues or cells that I showed you are not implantable. Okay, these are to simulate or to mimic anatomies in a lab for either surgical planning purpose or for device testing purpose. Basically, the funda is like, let's say you need to practice a surgery in a lab before you get into actual complicated surgery. So these 3D prints will give you a replica of the human anatomy in a lab environment, and these are essentially simulated photopolymers. If I talk about can we print real tissues or cells with bioprinting, yes, it's possible. And these are basically extracts or synthetic version of extracts from the real patients or from the real people. But that's something that real implantable tissues is something which is a little bit far away. The materials that we use to create mimic anatomies are essentially simulated photopolymers. Then another question is, what is my view on FDM or polymer composites in the field of material and in medical field? See, not all materials can be used for medical field. Basically, we need to understand what we are doing. So most of the materials that we have used in applications like surgical guides or applications like like the juvenile arthritis splint that I showed you are medically approved thermoplastics. So there are many, like we have a medically approved version of ABS, a medically approved version of polycarbonate, a material called PEEK, polyether ether ketone, Ultem 1010. So these are materials that are certified these are materials which are certified to come in blood and tissue contact. So not any material can be used, but then there are specialized materials which are certified, which are very commonly available even in the Indian service providers that can be used for these applications. Can 3D printed cadavers be a real thing with easy availability? For an individual level, maybe not to a very big extent. For companies, yes, I mean it is a reality. A lot of organizations are using it. A lot of hospitals are using it. For an individual, maybe for an individual like a student or an individual like an individual researcher, it is available in the market, but it will be a little more expensive. But I'm pretty sure that, let's say I am an individual researcher. If I try to find a cadaver, actual cadaver, I'll not be able to get one. But if I try to find a 3D printed anatomy, I will definitely be able to get one. Nobody is just going to hand me over a cadaver or a dead body, but I can go to any 3D printing service provider and he can give me a digital anatomy. Are there any acrylate photopolymers which can be directly used for implantation? Yes, PEEK. PEEK is not a photopolymer but a thermoplastic. PEEK, polyether ether ketone, which can be directly used as an implant. Also PMMA, but commercial 3D printing of PMMA is something that is not developed completely yet. Okay, any further questions?
Thank you, sir.
My pleasure.
Now we would like to have the next speaker, Mr. Yan Lu. Mr. Yan Lu was a product manager of Micraft 3D printer, Young Optics Inc. He had conducted market research and user experience studies to assess the usability and development of 3D printer technology. He has completed his bachelor and master degree in anthropology from the National Taiwan University. Now, I welcome Mr. Yan Lu on the platform to present his speech on the topic, Optical 3D printing and its application in dentistry and medical care.
My name is Brian, and I'm British. And we are from Young Optics 3D printer team, and we are in charge of the support and sales work. And it's our honor today to introduce you our 3D printer. And before our presentation, we would like to start with our a video. Okay. Okay, here let's start with our presentation slide today. So, Young Optics is one of the global leading companies in optical design and manufacture. And Young Optics provide optical product. We use our own optical technology to develop 3D printer from 2012. Our headquarters is based in Taiwan, but we have R&D team both in Taiwan and Germany. Our printer system is based on open system, so the end user can use third-party resin, third-party material for their own use on our printer. Until today, we've built up global sales system, and we've sell over 50 countries. Let's begin from the benefit of digital dentistry. Digital dentistry is a trend over the world. It brings too much advantages and significant impact to the dental industry. Dentists and hospitals invest on scanner, CAD system, 3D printer to improve their efficiency of work. Digital dentistry can simplify the workflow. To save time and reduce the cost, dentist works with digital files instead of stone model, and it's easy for them to go for CAD design and model manufacture. Besides, digital dentistry provides a smooth treatment experience for clients. 3D printing played an important role in digital dentistry. Compared to milling machine and traditional workflow, 3D printing can save material waste. 3D printing can speed up the production time and improve the accuracy, and the price is affordable for dentists and hospitals. There are several types for 3D printing, but there are only 3 types, which is suitable for dental. The first is DLP, and the second is SLA, and the third is LCD. All these 3 types is kind of VP technology, which use UV light to curing the liquid material to make the material become solid after curing. Here I make a comparison for these 3 types technology. DLP use LED as the light source, so the lifetime will be much longer than others. SLA use laser as the light source, so its printing time will be worse than others. LCD use panel as light source, so its lifetime and power output is its weakness. Here is our product portfolio. On the left side is Makeup Ultra and Makeup Hyper and Prime. It's our desktop model. And on the right side is Advanced and Profession. It's our standalone model. Makeup Ultra is the entry-level desktop model. It has full HD projector inside and has 5 configurations for different resolution. This model is suitable for small dental dentists or hospital. Prime and Hyper is our new desktop model we just launched in this year. Prime has higher resolution. The printing path is more smooth on the surface. Both advanced and professional models are for large production demands, such as big dental labs or dental hospitals. Advanced has the biggest printing size, and professional use 4K resolution light engine, so it can print detailed on the surface and its structure. But meanwhile, the printing size is 4 times bigger than the desktop model. The design of our 3D printer is all based on our optical pattern. We calibrate every printer to make image very excellent. So the printing path has wonderful accuracy and precision. It can reach less than 100 micron on the surface. Besides, we have special design on our peeling system. We have dual direction on the peeling, so it can reduce the peeling force when printing layer by layer. And it can make the printing path more smooth in the surface, and it has high quality. All our printer is based on open system, and we have partnership with many worldwide leading material suppliers, such as Dtex, Nextgen, Keystone. The user use our printer that has many biocompatible resin for optional, and they can use their own material as well. Here is the production estimation for dental models. So for advanced model can print 14 arches in one plate, and its daily production can reach more than 300 pieces in one day. And profession can print 12 arches in one plate, and its daily production is close to 300 pieces. Prime and Ultra can print 4 arches in one plate, so its daily production is more than 100 pieces. Here is our 3D printer application for medical care. The main application is surgical guide for orthopedics, assistive device for medical treatment, surgery development and practice. And the last one, teaching aids for medical training and communications. This page, we show the soft material applications. The soft material can be used in dental gingiva, hearing aid, colored brace, and organ printing. The last page is the 3D printing device for academic provision, such as nasal swab, mask, eye protection. So here is the last page, and we have another video which talks about our application in dentistry.
Thank you so much for your talk. Are you complete with your talk?
There is another video.
Okay.
Here. Sorry, I am not really familiar with the interface. 怎么出去？对，如果要找那个 video， 在这里here。Okay, so that's the end, and thank you for all. For more information, you can visit our website or send email to us. And now we can begin the Q&A.
darken it with black pen. 10. Okay. Thank you so much for your nice talk. And there are some questions like while performing surgery, there are some tissues which are not stable, like the heart, which is pumping, and lungs. They are also in motion. So can 3D printed cadaver mimic these situations?
Currently, we are focusing on printing the tissue-like structure. We have some flexible resins which can perform same kind of structure. Currently, we just have resins, and we have successfully printed the heart-like model, which can be flexible and which are more.
Can bio-based biocompatible surgical guide resins also be used for implantation?
They can be used as edible materials. We have some kind of FDA and TFDA from our resin manufacturers and our collaborators. If you want, then we can specifically suggest any kind of material for your purpose.
Okay. So thank you so much for your informative talk, and I don't think there are any other questions. So I thank you for sharing your knowledge with the participants. Thank you so much.
Thank you.
Thank you so much. Now we have come to the end of day 1. It is quite informative and hope all participants must have enjoyed the talks. Tomorrow you may use the same link and join us by 9:50 a.m. for day 2. Thank you.
Yes, we will provide the recordings and videos. Tomorrow time is 9:50. You have to join. Thank you.
Dinesh ji, are you there? Dinesh ji?
Yes, बताइए.
हाँ, तो क्या आज का सेशन
हाँ, हो गया. We will meet tomorrow. All speakers are done.
Okay then. And we will post the feedback from on 16th.
Yeah.
Thank you.
Okay.